Hello there, and welcome to lesson number 4 in our series on descriptive geometry. Today we're going to be learning more about true length lines and the application of lines that are in true length. So to start off today, let's do a little bit of a refresher. We're going to do this simple little problem here. We're going to try and make a right profile view of this rectangle right here. So in order to start off, we're going to move to the folding line layer, and we're going to draw folding lines between each of the views. The horizontal view is up top, the frontal view is down below. Again, I know that because of the superscripts here on the letter A. And I need to make another folding line. Somewhere out here, we'll say. We need to identify each of these folding lines, so I'm going to copy some text in. That'll be the horizontal side, that'll be the frontal side. Down to about the center of that folding line there, where we will rotate it into position. And this will be the right profile view. Alright, the next thing to do is we're going to move to the construction layer, and we're going to draw a bunch of projection lines. So we're going to project each of these points, A, B, C, and D, all the way out. There. Pick that line up and copy it. B, and C. Type LEN for length, DY for dynamic. I'll pick up each of these guys so that they're roughly the same length. The next step is going to be to offset. So open the offset command. We'll specify the distance for A is that much away from that offset line. So 2 views back, this view, 1 view, 2 views. So we're making all our offset measurements from here. Notice that the offset distance from A to the folding line and B to the folding line is the same. So we pick up 2 points. There's point A, and there's point B. We can now delete that offset line, and we'll repeat the same process. Offset for point E to the folding line. And we'll notice that the offset distance for E to the folding line and C to the folding line is the same. So we'll draw 2 circles. One there. One there. We'll move to the object layer. We'll connect all of the projection lines to their points. So now you're starting to see that the process is pretty standard. Every time you're making the view, you're just running the same procedure over and over again. It can get kind of tedious after a while. And now we will identify each of these points. This guy's going to be point C, that'll be point E, that'll be point B, and that'll be point A. And that A should have a superscript above it, identifying it as being on the profile plane. And then we would shorten these extension lines up. But that's the basic process for creating any view, really. So let's go ahead and delete all of that work we just did. Yeah, that guy too. Cool. Now let's go over here to SOLIDWORKS and take a look at what's going on here. what I've drawn for you here is I've drawn a plane that's colored in black, and we have two lines. One of these lines is actually in true length, and one of these lines is not displayed in true length. And you can't tell the difference just looking at them. Is it the red one or is it the green one? Can't tell. I cannot express to you the importance of making sure that your line is in true length, or knowing that your line is in true length, and you need 2 views minimum to determine that. So let's take a look at an alternative view. I've drawn a little blue plane right here, and if we look normal to that plane, if we look so the camera is looking in at this plane, come on, there we go, normal to the red plane, you'll notice that the red line appears as a single dot, and the green line appears as a line. This green line is the line that's not in true length. The red one was the line that was in true length. So let's take a look at that and let's kind of just pan around it. So when we were looking at the plane, this red line was contained on that plane, and this green line was not. So this tells us something really, really important about true length lines. First is that if you want to get the point view of a line, if you have that line in true length, all you need to do is you just need to make another view that's pointed directly at that line, perpendicular. So the viewing plane is perpendicular to the true length line. And if you do that, you get a point view. But even more critical is look at what happens to the plane. If we were to try and make a point view, let's go ahead and do that actually really quickly. I'll go to reference geometry, and I'm going to click there, and I get a plane. And let's look normal to that plane. That'll give me a point view of this green line here. But check out what happens to the black plane in the process. Here, you see a point view of the green line, but look, the black plane, you can still see it. You're not getting a view of that that's going to be useful to us later. Let's go ahead and hide you. But if I return to looking normal to this red line here, the black plane ends up looking like a single line. In fact, what's happening is we're looking at the very edge of that plane, and because a plane has no geometric thickness, it ends up showing as a line. This is called an edge view of a plane. You're really familiar with that because over in AutoCAD we've talked a bunch about how these folding lines are really edge views of planes. Well, if you have a true length line and you look normal to that, the plane that contains that line automatically appears in edge view, and this is a really super useful thing. So let's go back to our example over here, and let's try to make an edge view of this plane. If this guy represents the plane, then let's try and rig it so that we see only the edge of it. Let's do it the hard way first, and then we'll do it the easy way. It doesn't matter which view we start from, either the frontal plane or the horizontal plane, and we can make a view either or. It doesn't matter. So we're going to do it once the more difficult way, and then we're going to try to exploit some inherent geometry here to do it an easier way. Now, when you need to make a line true length, it doesn't have to be a naturally occurring line. It can be any line that you draw. So we're going to go to the construction layer here. I'm going to pick the point B, just for no real reason other than if I draw it back straight across, I get a horizontal line. And I want it to be a horizontal line because it lines up with this view, which means if I take the intersection of this line right here and move it into this view over here, this line, that line that we create, is automatically in true length. So let's do that. We're going to take another line and we're going to draw from this point right here up to the line A to E, which is that line right there. So we're going to drag up. Right there. And then we're going to connect that line to the point B. This line and this line are the same thing, except This new line right here is in true length. We'll take and we'll rotate that guy a little bit. And then move it into position there. Great. Always remember, you want to be labeling these things as you go. If you've established that a line is in true length, don't wait until later to try and remember what was in true length and what wasn't in true length. Label as you go. It saves you so much time. Now, if we wanted an edge view of this plane right here, what we're going to do is we're going to go to the folding line layer, and we're going to make a view that is perpendicular to that true length line, and only that true length line. Then we're going to play the same game. Go back to the construction layer. I'll type LEN for length, DY for dynamic. I'll take these guys and stretch them out a little bit. Hey, all right. Oh, I forgot to label this folding line. Man, that's no good. We'll copy this text right here. And drop the middle of those letters right about there, and then rotate them around. This is going to be auxiliary view 1, so we're going to label that as 1, and that guy should be a horizontal, so we are good with our folding line. Now, the next step is we're going to offset. We're going to go 2 views back, so this is the view we want. 1 view, 2 views, so this is the view we'll be measuring from. Offset, take the line A to here, here to here. We'll repeat the process for point B. We'll zoom in real close so that I don't get confused between the folding line and this projection line right here, and that can be something that's really dangerous moving forward. There can be a lot of geometry packed into really close quarters. So, if necessary, just zoom in as much as you need to make sure that you are picking the correct thing, or you're not getting fooled by any O-snaps or anything. Alright. That was an offset for point C, which is right there. Just following that line back to there connects to that point C. Then we need one more offset from point E. Why they call that point E and not point D, I don't know. Messes with my engineering sensibilities, not have things alphanumerically ordered. And to E. Hey, check it out. All the points, they line right up, just like that. So, we'll go to the object layer. Boom. You are looking at an edge view of this plane right here. So that's one way. And I mean, obviously we'd be taking these letters and we'd be copying them over to the individual points right here, because that point C is not the same as the point B or the point A. So it's a whoop, E, and then that'd be B, and that would be A. And again, I would want a superscript above that A, indicating it as 1. So let's not cheat, let's not. Let's make sure you guys are getting a quality instruction, some quality examples. In fact, actually, we'll just trim and then just cut those guys out. And the last thing for us to do is clean up, so take lengthen, dy, turn off my O-snaps, and alright, here's a really good question. How come I foreshortened this guy, but I left this guy connected here? Well, that's because this geometry, even though it's on the same layer as the projection lines, it's not quite the same thing. In order to state this intersection with the line AE, I have to make sure these points are connected. So I can't foreshorten them, because if I foreshorten, I lose the ability to describe to the person reading my drawing that there is actually a point that I'm talking about, a finite little point right there. These projection lines are not actually portions of the geometry. This is actually a reference line that I'm using to construct this view over here. It establishes the direction that that view is going to be looking at this plane from. However, these guys are not actual geometry. These are just references to help the viewer track. Oh, from point A to point A. Oh, that must be point A over there. So that's why some points are connected and some points are not. If this is a projection line, if this is really just to connect these 2 points right here and show, oh, this one came from this one, you want to foreshorten them. If you actually had to make an intersection right here with a line in order to establish some sort of true length line, that needs to actually be touching the line of reference that you're trying to connect to. So this view is fully completed. We're looking at an edge view of this plane right here, and all of that was thanks to the true length line. So that was the hard way to go about this. Let's go the easy way. Starting over, if we went from this view into this view, I want you to notice something about the line EC and A to B. Both of these lines are frontal lines because they're parallel, with the folding line, horizontal and frontal plane right there. Which means that if these guys are parallel, then the same line down in the frontal view must be true length automatically. So, oops. Now, even if I'm not going to use both of these lines to establish an edge view of a plane, I'm still going to label both of them as true length for you. This would be considered overkill, because you don't need to label everything true length if you're not actually using it. So let's only use A to B. So even though this line is true length, I'm going to delete this guy right here. Now, let's go to the folding line layer, and we're going to establish a new view. But we're not going to establish the view, a regular profile view. Remember, we did that earlier, and we came up with kind of a squished rectangle, not an edge view. However, if we make a very particular view, and it's perpendicular to a true length line, and I pick that up and move that out here, I type LEN for length, and DY for dynamic, and I just extend that guy out a little bit, this particular view is going to result in an edge view as well. So we'll go to construction. Oh, it's not a perpendicular line. copy. Notice how those lines, they overlap with each other. So we'll take len, dy for dynamic. I'll extend these guys out a little bit. We'll go ahead and delete those. They line up with each other. It's not a particularly big deal. Oh, again, I have neglected to label my folding line. And that's good enough. We'll call that auxiliary view 1, and I believe that's the frontal plane, so we are good to go. This is the view we're trying to create, so 2 views back, 1 view back, 2 views back. All of our offsets are going to be taken from this view here. So I'll type in offset, and we'll go for point A. Point A right here also lines up with that. Point B is the same offset. So A and B are sitting literally on top of each other right here. It's as if you were looking, say, at this plane right here. If you were to look edge view down here, you would see this plane, this point right here, and that point, and they would sit almost on top of each other, even though they were 2 separate points. Same thing's happening here. B is sitting on top of A. Now we need to, what were we doing? We were offsetting from, we'll just pick the point E. E and C. Alright, cool. We can get rid of that. Get rid of that. Go to layers, go to object. Connect these guys up. Oh, trim command quit early on me there. So now the question is, how do we label these points? So here's what you do. We're going to take B came first, then comma, A came after, because if I look in this way, I hit B first, then A. Over here, C is the first point I hit, then E, so I'm going to put commas right there. I'm going to take len, dy, shorten those guys up, and there you have it, a planar view. The only thing that we would need to do is we would need to get a superscript 1 above the A, and that can be a little bit troublesome because this is a single line text and not a multi-line text. It would take a little bit too long and put us off track to figure that out. So I'm going to leave that as a puzzle for you to solve. But again, the major problem that we were facing has been solved here. We're looking at an edge view of this plane. Got our points all labeled. Everything's all set. No fuss, no muss. Pretty snazzy. So you can create edge views in referencing any direction. You could go from this view if you wanted an edge view from this view right here. You just need a true length line. And you do that by making a line. You just make one up. So we went from point B to point A to E. We created a true length line, and then we made an edge view. And then here we created, we went the opposite direction, and we noted that this guy was already useful. This guy being parallel to the folding line here would create a true length line, and we exploited that in order to get an edge view here. And I think I had a copy, but I think I talked about everything I wanted to talk about. So that's going to end our first example. Okay, so we've talked about how the application of a true length line is getting an edge view of a plane, and that's going to be useful moving forward. One of the other common applications of getting a true length line is getting a point view of a line. Notice how in our model here, there's the edge view that we generated in one of our previous examples, and here's a point view of a line. Every edge view, every time you do this process where you're getting a true length line and you take an auxiliary view that's perpendicular to that true length line, you get not only an edge view, but you also get a point view. And one of the applications of that is for establishing the clearance between objects. But before we do that, let's do a little stripped down version and just repeat the process again. I have 2 point views I'm trying to make, one for the line M to N and another for the line A to B. I've already drawn the folding lines here for a horizontal and a frontal view, and I want you to notice right away that this line M to M is parallel with the folding line H to F. And that means that the line in the next view down, right here, is going to be automatically true length. So I drew an extension line off of that. I did a folding line that's perpendicular to that true length line, and what comes out is point, established here by this object cross right here. Notice the line, notice the notation for that point. If we draw this way, the first thing we encounter is the point M, then the point N, so we write it M, comma, N, and a superscript 1 because we're on plane number 1. Let's go ahead and do that for this guy. Now, we don't get any sort of shortcuts because neither of these lines in the front view or the horizontal view is a frontal line, or a horizontal line for that matter, so we can't immediately establish a true length. We'll have to force a true length to appear. We'll have to force a true length. And the way we're going to do that is we're going to copy that plane right there, the folding line, and then I'm going to rotate it so that it matches the line A to B. And then I'm going to move it one more time and get all of it. There we go. And then we're going to take a view normal to line AB, and that's going to force the line as it appears over here to be in true length. So I'm going to change the layer to construction. I'm going to copy those projection lines over to here. I'm going to type LEN for length, DY for dynamic, and I'm going to extend them out a little bit. There we go. So here's the view I want to make. One view back, two views back. So we're going to do our offsetting from here. I'm going to type offset command, point A to the folding line to A. Draw a little circle right there. That's point A. Repeat the process again. Offset, point B to here. Draw a circle. 1. We're going to move to the object layer. And we're going to connect those 2 points. We'll delete those circles. We will trim away the excess. And now we'll label those points. Okay, there. We'll need to make sure that our identifier for this folding line is correct. This should be, these letters should match. This is both the horizontal plane. This should be auxiliary view 1. So that right there should be a superscript 1. And the way I'm going to do that is I'm going to edit my multi-line text box here. I'm going to put a 1 and then a caret. I'm going to highlight it, right click, go to stack, delete both of these, and get Boolean, dy for dynamic, turn off my O snaps, and one last thing to do. I'm going to pick up that text, copy it over to here. This line is now in true length because we took an orthogonal view, a normal view, to the line AB, which means this line over here is in true length. One last time, rotate this bad boy in. Alright, so now we have a line in true length. In order to get a point view of this line, what we're going to do is we're going to go back to the folding line layer. And I need a view that is perpendicular to the true length line. Pick up these guys right here, and I will copy them. Drop them right there, maybe. Rotate them. Yeah, that's pretty good. And we'll move them kind of more into position. This is going to be plane number 2 because we've already used auxiliary view number 1. That was this guy over here. And this is going to be auxiliary view 1. So 1 and 2. Here's the view I want. So I'm going to count 2 views back, 1 view back, 2 views back. I'm going to do my offsetting from this view here. So offset. Point B to that folding line, B to that folding line. Let's throw in a projection line. There to there. This distance from B to the folding line is the same as the distance from A to this folding line because AB and this folding line are parallel to each other. So our point is going to appear right at that intersection right there. We'll say that's 2 right there. I'm going to trim away the outside of this guy, just there, like that. Delete that guy. And I'm going to set these guys to be on the object layer. So I want these to be objects. And then I will reconnect that point right there. Mouse freaked out there for a moment. Boolean, dy for dynamic, and then we will foreshorten these lines of projection right here. And then we need just a point to specify this guy. So we'll copy this guy, drag it over like this. Looking in from this point here, I pass the point B first, then A1. So I'm going to edit this guy. I'm going to put a B out front. Put a 2, then a caret. I'll highlight, and then stack. If the stack option is not there, when you right-click, you're working with a single line text instead of multi-line text. It needs to be multi-line text if you're going to have superscripts or subscripts. So let's see. That's good. That's good. So now we have a point view of that line, which is what we were after in the first place. So the process is the same, whether or not you're making a point line or you're trying to make an edge view of a plane. One of the applications that I mentioned earlier for finding a point view is that you can establish clearance between objects. So that's what this problem is going to have us do right here. We have a cylinder, like a rod that's 100 millimeters in diameter, and then there's a sphere that's 150 millimeters at diameter, and it wants us to determine what's the minimum amount of space between those objects. So the sphere is going to be established. The center of that sphere is right here at the point O, and this line M to N represents the center line of this cylinder. So let's take a look at a model. I'm going to bring back one of the earlier models we were looking at, which is these 2 rods. We were talking about visibility a while back. So there's clearance between these 2 rods. There's a distance from this rod to this rod if we were to measure that. And you can be deceived by distance if you're just kind of randomly looking around. But if you establish one of these cylinders in point view, which is what you're seeing here, the only difference between the model and here is that you're not showing the additional cylinder. We're going to show that at the very end. For this problem, we're really only looking at kind of the axes, the very center of the cylinder, right through here and through here. But onto my point. If you get one of these cylinders in point view, then all you have to do is measure the distance from here to that line right there that represents the tangent edge of the other cylinder. That's what they're talking about when they say clearance. So that's the game we're going to play over here. We're going to try and get this line to be a true length line. We're going to make it into a point view. This point O is going to come along for the ride. And then once we're finished, once we've established this guy in point view, we're going to draw a couple circles to represent the sphere and the cylinder, and then we're going to measure the distance between them. Let's get started. So first step, as always, is I drew a folding line right here, and I specified what it was. Horizontal view up here, frontal view down here. Neither of these lines are parallel with my folding line, so I need another view in order to force this guy to be in true length. So let's copy this guy right here, take it over to here. Let's rotate it now so that it lines up with this guy. Let's move it one more time. Perfect. Let's change the indicators over so they look like they should. This is the frontal view over here. This is going to be auxiliary view number 1. That looks pretty good to me. So now, next step is we're going to go to the construction layer. I'm going to draw lines of projection for that point, and each of the points M and N, I'm going to delete that one right there. LEN for length, DY for dynamic. Alright, here's the view I want to create over here. I'm going to go 2 views back. 1 view back, 2 views back. So this is where I'm going to be doing my offsetting. I'm going to type offset from N to here. That's the point N, so I trace it forward. That's the point there. We can delete that folding line. We'll do the point M, so offset from M to folding line. That's the point M. There we go. 1. We'll delete the folding line, move to the object layer. Connect those 2 guys there, and perfect. We will trim these away, and that'll be the line MN. This guy right here, point O, we'll repeat the same offset that we've been doing from point O to folding line, offset, and then we'll go ahead and just copy that guy. And perfect. That's the point O on plane 1. That'll be the point M. That'll be the point N. I can get rid of that guy. Adjust that to be N. Put that on plane 1. And I think we were ready to do some cleanup. And one last bit, the most crucial bit. This line is now in true length, so we're going to specify that as being in true length. Rotate it so it matches up with that. since this is not an object, it's actually the center line of a cylinder, we need to make sure it's on the same layer. So this is a center line, this is a center line. It'd be kind of weird if it turned into an object all of a sudden. So now that we're in true length, we can get a point view. So move back to the folding line layer. There we go. And we'll make a view that is perpendicular to the true length line, right there. We will copy that text right there. Rotate it to match. That's about right. This is on plane 1, so we'll specify that. We've already used 1, so we're moving up to 2. I'm going to adjust the length of our folding line so it covers all the pieces, right, including O. It was too short there, and I can't draw a projection line if the folding line doesn't fully encapsulate everything that's here. Next step, we're going to move to the construction layer. Going to draw projection lines here onto there. We'll extend those out. Great. This is the view I want to create. 1 view back, 2 views back. This is where I'm going to be doing my offsetting from. So, offset. I'm going to pick point N first, from that folding line to there. So point N is going to be located right here. The same thing I did before. I'm going to trim all of that and put that guy on the object layer, since I'm looking barrel down at that point M to N. The construction layer, so I'm going to connect up point to that point right there. Then I need to offset again. This time I'm going to go from the folding line to O. Over here. Boop. I'm going to take this guy, extend it just a little bit, copy that point, move it to that intersection right there. Pick that guy up right there and delete. This guy is now on point 2, so I'm going to specify that. And this guy is point M1 to N1. So let's go ahead. I'm going to show you how to make, we're going to click on multi-line text right there. And I'm going to make an M2 caret, comma, N. We're going to go to properties, make this thing more of a reasonable size. So we'll say the text height is actually 2.7. There we go. Looks to be about the same size. We'll adjust that so it's not on the construction layer, it's on the text layer instead. And now because it is a multi-layer, or a multi-line text, I can click stack and I can make a superscript right there. So that's how you make a multi-line text item from scratch. I think we're almost there. We just need to foreshorten some stuff. Shorten that up. That guy. That guy. That guy right there. Alright, so now we're looking down the barrel of the cylinder right here. That's the center point of the sphere. So let's see what the problem says about how big they are. It says that the diameter of the cylinder is going to be 100 millimeters, but you have a scale to worry about of 1 to 10, So the diameter of this thing should be 1/10 of that, so it's going to be a diameter of 10. We'll go here, we're going to make it an object, so let's go to the object layer. We'll click on circle. There we go. Over here, we have a 150 millimeter diameter sphere. We'll divide by 10, that's 15. So D for diameter, 15. We'll go ahead and just move these points around so that they look good. There's no real rhyme or reason to where they go. I just want to make sure that whatever it is I'm saying it reasonably clearly so my reader can follow along. Right there, that's definitely not clear, so I'm going to move that over to here. That guy's definitely not clear, so I'm going to move that maybe down to there. Everything else looks pretty clear to me, so now we're ready to measure. I'm going to show you the dimension layer in red so that we can really see it. And then we're just going to trim out that excess. There and there. That distance right there, that red line, that is the clearance between the sphere of 150 millimeter diameter and a cylinder of 100 millimeters in diameter. So, right here, the same thing we were doing. Distance from here to here. That's what we've established over here. And again, the way we did that was we put one object in true length and then took a point view. And it's almost like we took it out of the game, right? There's no foreshortening or anything funky we have to worry about. It's whatever it is, that distance, we've reduced it geometrically into a single point, and that's really handy for us. And then we just follow the procedure through. So there you go. That's going to end our second example for this video, and that's going to end lesson number 4 for us. So I'll see you guys next time.